Hi, students. We're going to talk about the integrals using chain rule. This is the proof. It's a change of base from x to a variable, which is u. This is the proof. You can read it by yourself. We're taking the composite function. And here, this is the proof of a composite function. What concerns us at the end, if you have integral of fg of xg prime, where you have, for example, a variable x of composite function, you can change the base from x to a variable u. From this property, the formula of chain rule, we have this integral. It's the same as the integral with the x, but here I'm using what's called change of base from x to u. We need to memorize all of these formulas. To understand, we have 20 problems, which will be a summary of using all these kind of problems. This part is simple. We're going to start by the first one. Here I have integral. First of all, when I want to change the base from x to u, my first concern is not to get any more any x. So here it's of the form, as you can see, sine u. So I'm going to take this to be u. If I take this to be u, let u equal 2x minus 3. Derivative of 2x minus 3 is 2dx. So I start 3, okay, sine u, because I replace this by u. And dx here is du over 2. All right, dx. So if you replace it 3 over 2, because it's a product outside, an integral of sine u is minus cosine u. So it will be minus 3 over 2 cosine u, where u is 2x minus 3. Don't forget to put plus c. If you have this one here, my aim, the u I want to find, I need to cancel all x's. I cannot pick 2x to be u because I cannot cancel this expression. So I take this to be u without the square, okay? So let u equal 3x squared minus 5. Derivative is 6x dx. So I start. 2x is 2x. I said this is to be u. I have it square. And dx is du over 6x. 2x and 6x, as you can see, the x cancel out. Remains 1 over 3 inside. So it's of the form u and du. So you add the power n plus 1 over n plus 1. And you replace u at the end. Okay? More examples. Here I have this big expression. Don't be afraid of this expression because it's very simple. I cannot pick the u up because I cannot cancel the square root down. So I need to pick something. If I do the derivative, I cancel the rest. So I'm going to take this to be the u inside the square root, not the square root, inside the square root. So if I pick this to be u, 2 sine 2x minus 3 plus 5x squared plus 2, if I derive it, so it's of the form sine u, it will be 4 cosine 2x minus 3 plus 10x, and don't forget to put dx. So this is, I said u, and because it's a square root, I put it u power half. This is up. Now dx is the u over this whole expression. As you can see, I can put 2 in factor so that I'd be able to simplify these two. Half outside, you have down, I can write it up. So you add the plus 1 over, u minus half plus 1 over minus half plus 1. So 2 and 2 cancel out. I'm left with square root u. And u is what? This whole expression. Here, the same story. I want to pick this to be u. If I derive it, this is the derivative. Don't forget to put dv. So you have 10 root v over u squared. And dv, if you do cross multiply, minus 2 du over 9 we have and we have. As you can see, we're canceling all the variables, remains only the u, minus 20 and the over 9, here 9, and u squared down, you put it up. Integral of u minus 2, it will be u minus 1 over minus 1, and then you replace u as it is. More examples. Here, I will pick this to be u, because if I pick this to be u, I will get the other one without the square root. So this is u. If u is 1 plus cosine 2x, this is the derivative, cosine u minus u prime sine u. I start. Here it will be, instead of saying radical 1 plus cosine 2x, u power half, because this is u. And dx is du over minus 2 sine 2x. Sine 2x cancel out. Minus 3 over 2, so it's u power half plus 1 over plus 1. You're going to get u3 over 2 over 3 over 2. These two cancel out. I'm left with minus u, which is 1 plus cosine 2x power 3 over 2. Here, I cannot pick tangent to be u because the derivative of tangent secant square, I don't have secant square to cancel. So I pick u inside only. So the derivative is 2 dx. So I start 3 tangent square, this is u, and dx is du over 2. So 2 and the 3, we take it outside, 3 over 2. I'm left inside tangent square u du. And in the property, derivative of tangent square u is tangent u minus u. So the answer will be 3 over 2 into tangent u, it means 2x plus 1, tangent 2x plus 1, minus u is 2x plus 1 plus c. You need to memorize, as we said, the formulas. Now, in number 7, you have this one. I cannot pick, as we said, cotangent to be u because the derivative of cotangent is minus cosecant square. I don't have minus cosecant square to pick, so to cancel, so I pick this to be u. So 2x squared plus 1 derivative is 4x dx. So 3x into cotangent square u, and dx is du over 4x. X and x, as you can see, x are always canceling. 3 over 4 cotangent square u du, and the formula say it's minus cotangent u minus u. Just I write it as it is, and I replace here u and u by its value, which is 2x squared plus 1. Here I have this expression, then I have power 3 over 2. So directly my hand go to that one. Why? Because without the power, because I have the power, if I pick this to be u, I cannot cancel this whole expression with the power 3 over 2. So let u equal cosine 2x squared minus 5 minus 1. Let us see if we can cancel all x's. This is cosine u minus u prime, so minus 4x sine 2x squared minus 5, and derivative of minus 1 is 0 dx. So let us start. So this is as it is. Here, this is u power 3 over 2, and dx is du over minus 4x sine. So as you can see, I can cancel this whole one and this one here. I'm left with what? 2 over minus 4 outside and minus 1 over 2, and u power 3 over 2, so it is of that form. You add the plus 1, you're going to get power 5 over 2 over 5 over 2. 2 and 2 cancel out, so minus over 5, and the u is cosine 2x squared minus 5 minus 1 power 5 over 2. Number 9. So directly, when you have an expression where denominator is power 1, try to think to take directly denominator because it will be of the form du over u. If not, we're going to search for something else. I cannot pick first of all numerator to be u because I cannot cancel this expression with the minus 3, but I will take the denominator. So u equal 5e power x plus 1 minus 3. Derivative of exponential is u prime eu, so 5ex plus 1 dx. So I start, this is as it is, this is u, and dx is du over 5ex plus 1, ex plus 1, ex plus 1 cancel out. As you can see, I'm left with du over u. Du over u by formula is ln absolute value of u, and this is what you replace it as it is, which is u. Here I have this expression. Either you're going to pick secant or tangent. If you pick, for example, or if you pick tangent, it will be secant square I don't have. If you pick secant, you're going to get secant tangent. So it doesn't work. So that's why neither you can pick secant because the derivative is secant tangent. I don't have another secant with the tangent. If I pick tangent, I can derivative of tangent is secant square x. I cannot. So in that case, when you cannot cancel the rest, so let us pick the middle. We know that if you look at it, it's of the form secant u tangent u, but suppose you didn't realize that. So let us pick inside to be u. Derivative is 2x dx, so 5x as it is, secant u tangent u, and du is dx is du over 2x. X and x cancel out, 5 over 2. You know that this is the formula secant u tangent u, which is secant 5 over 2 secant u, where u is x squared minus 1. More 11. Here I have this one. So I cannot pick exponential because I cannot cancel secant. And secant derivative is secant tangent I don't have. So I pick this inside to be u. So derivative is this one. So I start secant square u, and dx is du over this one. These cancel out. It's of the form now secant square u, which is a formula tangent u plus c. Here, if you pick tangent, if you pick first of all secant, derivative of secant is tangent square. I have tangent power 7. But if I pick u to be tangent, derivative of tangent is secant square. So this is the right thing to do. So let u equal tangent x over 2. Du is 1 over 2 secant square x over 2. If you do it, u7 secant square x over 2, and dx is du if you do it cross multiply, 2 du over secant square. As you can see, I'm canceling here 2 outside. It's of the form un, so it's u8 over 8, where a is tangent x over 2. Here now, certainly I cannot pick sine to be u because the derivative of sine is cosine. I don't have cosine. I pick inside to be u. So this is its derivative. So x1 over 3 sine u, because this is, I name it u, and dx is 3 du over 4 x1 over 3. x1 over 3 cancel out, 3 over 4 outside. Sine u is cosine u minus cosine u, as you can see. Here, certainly directly it must be cosine, because the derivative of cosine is what sine, and here I have a power, I don't take it. So the derivative here is this one. So I write these two as they are. Here u power 3. Dx, here I need to put dx is du over minus 2x sine square. 2x and sine square, x sine square cancel out, minus half outside the denominator down. I'm left with u3, so it's u4 over 4, where you replace u by itself, by its value. Now, this one, the degree down 1, directly I go to down to be du over u. Let u equal to x minus 3 sine x, derivative of this one. You know the derivatives. So I keep the one up as it is. This is u, and dx is du over that one, cancel out. Du over u is ln u, where u is this one. Here I have square root, directly I go to this one. U equal ln x. So derivative is dx over x. So I start 5, 2x, u power half, and dx is x times du. X and x cancel out, 5 over 2 outside, and if u power half down, I put it up. So it's of that form, un plus 1 over n plus 1. So you're going to get this answer. Now, here, for exponential, you can do it directly, no need to do a chain rule. For example, 3ax is a 3ax. We did it before. Here, you write it as it is. Derivative of minus 2x minus 1 is minus 2. I divided by minus 2. So if you divide by minus 2, you're going to get a minus 2x plus 1 plus c. You can do it a chain rule, but no need. It's very simple. Here, if you pick exponential to be u, it doesn't work because it's u prime eu. I don't have another e to cancel. Nor I can pick secant, because I cannot cancel that one. So I pick u to be tangent x. If u tangent x, derivative is secant square. So you're going to get minus au, and secant square dx, you can write it directly. This is all du. So the integral of eu is eu, so minus eu, and where u is the tangent x. We just replace it. The last two formula, two problems. Here, if you pick down to bu, you cannot cancel log. Okay, so first of all, because you have log base 3, you can write it ln 2x minus 1 over ln 3. You can write first of all that, you put it outside. Now, which one I want to pick u? I'm going to pick all ln. Why all ln? Because we know that derivative of ln is u prime over u. Okay, so if you pick all ln, derivative, it's 2 over 2x minus 1. So 2 over ln 3. Okay, you have u, the ln, 10x minus 5. Du is 2x minus 1 du over 2. As you can see, I can cancel these two, but I will get 5 in factor to cancel. So you're going to get, so 5 ln 3 outside, and u du is of the form u2 over 2, where you can get the answer. The last one, it's an exponential where base is 5. I cannot pick cosine because you cannot cancel this one, nor I can pick 5 power u. No, derivative is u prime 5u. I cannot cancel. So I pick the power to be u. If the power is u, this is the derivative. So I start. It's 5 power u. Cosine x dx directly, this is the u all. Okay. So integral of 5u, this is of the form 5 power u over ln 5 plus c. I hope that you got the derivative using chain rules. As I told you before, you need to memorize these formulas. I advise you, when you have a test, you when you pick you have the paper, to write all the formulas, and then to start picking the appropriate u, so that you can cancel or x's, and you're going to reach one of these solution of these properties where you can use it and get the answer. And see you tomorrow in class.